Hey friends, welcome to Coding School. Today the question that we are having a very interesting question, and I want you to know that this particular question was asked by Microsoft and Amazon. So as you all can see here, we are going to solve today the question populating next right pointer in each node. Basically, we need to connect all the nodes present in each level. Okay. So, for example, take this particular image and or tree. In this particular tree, they are in this particular layer, which is the layer one, which is where the my only root node is present. So, in this particular layer, there are no more nodes present, except this particular root node one. So that is why I will be connecting node one with null node. Okay, because there are no more nodes present after this particular root node in this particular layer. So in the same way, we will be connecting 2 with 3 because in layer 2, there is a next node for node 2, which is 3. So we will be connecting 2 with 3 and similarly 3 with null node because there are no more element after or no more nodes after 3. And same process will go on for other layers as well. So this is the basic or essential portion of this question. So much straightforward, isn't it? Now we all can solve it using a cube. It's a very simple way. But still, if you guys are wanting a video on that particular algorithm as well, then please let me know in the comment section. Okay. Now, without any further ado, let's look at our optimal approaches. Let's look at some optimal approaches. Uh, let's consider this particular tree again. Okay. So, if both the left and right child are existing for a node, then we can simply connect them, isn't it? Are you wondering how? It's so simple. Let's say we are dealing with a root called as x. Okay, let me actually write it down. It will be more intuitive. Okay, so let's say there is a left child for x, similarly a right child for x. Okay, yeah, so L and R. Good. Now I want to connect L with R. Okay, that is the only job that I'm currently having. So how can I achieve that? See, if I will write that whatever the left of my current root is, I will simply going to connect, or just connect by a pointer which is given to me, which is basically a next right pointer to its right. Okay, then it will be simply connected. These two nodes will be connected, isn't it? Isn't it that easy? See, here actually I am connecting the left with the right, and this is the standard way of doing that. Okay, so it's that simple. Okay, now for node one, it is okay to say that. Let's look at node 2 right here. Okay, so it also has two child, both left and right existing. Fine. We can connect these nodes like the previous way, but we can see there is another node in the same level as well, which is node 3. So can I say the next node for node 5, which is the right child of node 2, will be the left of node 3? Yes, that is true basically. But for the root node 1, there are no more nodes present next to it or present in that particular layer. So we can simply refer the next of node 3 as null. Okay, that is why we have referred the next pointer of node 3 as null. Cool. So in this way, we will, we'll be populating the next right pointer for all the left and right subtrees recursively. So in this way, we can very easily, solve this particular problem. So without any further ado, let's, jump into our code. So all right. So now I will be, for example, let's first of all, let's handle a very simpler base case. Let's say there is no root. Okay, there is no tree given to me. So basically in that case I can simply return a null. Otherwise, if that is not the case, okay, because if I would see here, then the number of nodes in the given tree is less than 4096. Okay, so that means it can or cannot be 0. It can be 0 obviously, but it may or may not be 0 anyway. So I will be implementing a function basically which will be of void type. So be with me for next 5 minutes. We will be covering this particular part. It would be very fun. So here I will be passing root as the argument, and I will be I'll be connecting whole different things, settle them up, and then I will simply going to return the root of the original tree. Cool. So now let me quickly implement this particular function. So basically it is of node type, as you can see, and here let's come to the main part, which is the best condition. So basically, recursion is all about handling the states. Okay, so if in some state I reach the left node basically, which is where the the down of left nodes. Okay, where there is no more nodes, which is basically referred to as null pointer. So in that case, should I need to take care of anything? No, because there is nothing. So that is why we need to come back from that state. So that is what we can do here. And as I have already discussed, that if let's look at it again. If there is a case where both of the children, or we can say the left and the right child, are existing for a given, for any particular node, then we can say that we can simply connect them. We can simply connect them, isn't it? So basically we can check that if the left and the right are existing. Okay, so in that particular case we can say that whatever the left could be, I will be simply going to connect it with the right node. Okay, oh I'm sorry, yeah. So in this way we can simply gonna connect the left child with the right child. And what about the next of the right child then? See, there can be two cases. So the first case is the root node is 1, and the second case is the root node is 2. Okay, so let's say the second, let's take the example for second case, because this particular case I have already explained to you in the beginning, but still let's look at the second case again. So in this case, there is one more node present as its next node in this particular layer. So that is why we can say that whatever the right element of my current root node is, I can connect it with the next of the current root, the basically the left node of the next of my current root node. Okay, that means I can connect 5 with 6. So 6 is basically the the left of the next node of my current root node. Are you getting me? So yeah, so that is the case which need to be taken care of. So I can simply gonna write that root of right of next. So what is it? Root, let's say this particular root of right of next will be connected to uh, I'll take you there. Root of next of left, okay, and that will be the case only when there would be a next, node present after this particular root, any root node. So I'll be I'll be telling that, if there is a next node existing already, like this particular node, then only I can say I will be connecting it with next left, okay. Otherwise, like this, but in the case one, where the root node is one basically, and it has nothing, you know not, it has no node next to it. So in this particular case, would 3 be depending on anything? No, because it has nothing. So that is why I am not going to connect it with anything. That is why I'll be connecting with it with null. So the pointer which I will refer it to will be null. I hope you are getting me in a very, very good way. So, after this, my work is done basically, and for this particular node, and I want every particular subtree just follow this particular approach recursively. So what will I do for this? I will going to simply, call for the left subtree and the right subtree, and all this step will be taken care of automatically. And yeah, so that's it. Can you believe? Okay. Anyway, so this is the recursive way. Let's run it to check whether it is working or not. Yeah. So it is accepted for this particular test case. Let's check it whether it is actually working or not. And it worked. So now the recursive way for implementing it was very easy, isn't it? And also it was taking some internal stack space. But if you would clearly read the problem statement and uh, everything present inside it, then you can clearly notice this particular line, which is saying that recursive approach is fine. You may assume implicit stack space does not count as extra space for this problem, but it basically matters. Okay, in real interview, the interviewer will ask you to just optimize it to the fullest. Okay, so in that case, you should have a very, very optimal approach with you to to speak out in that particular process. So for that, we will be discussing one more approach in our next video, which will solve it in order of one extra space, which means a constant space. Here actually we are not actually explicitly declaring any particular like q or something like that, but we are solving it in a recursive way, but the recursive stack actually taking space. Okay, so in the next video we will be solving it a figure of one extra space. That means we are going to implement in iteratively, and will try to reduce the any extra space, okay, implicit also. And the time complexity will remain same, which will be again order of n, where n will be the number of nodes present in the tree. And so finally, if you have any sort of doubt, please leave a comment below. Till then, keep coding.